Hello YouTube, hello viewers, and my dear students. I am Samson Adebisi, aka Prof-Sam. Today we'll be looking at Ohm's Law and some circuits. First of all, what is Ohm's Law? Ohm's Law states that the current I passing through a conductor is directly proportional to the potential difference V across its terminal with a condition, provided temperature and other physical conditions are kept constant. So mathematically, it can be written as V is proportional to I. That is, V is the potential difference. It's directly proportional to I. So now, by the time we change this proportionality sign to equation, we introduce a constant. Is that okay? V equals to Ki. But no, this is physics, not mathematics. In mathematics, K is allowed, but in physics, that constant is the resistance. So we say V equals to IR. That is the mathematical statement of Ohm's law. V equals to IR. It is a law propounded by George Ohms. All right, let's look at the first question. We have a circuit diagram here, and you have to calculate the potential difference across the 20 ohms resistor. This resistor, the potential difference across the 20 ohms, which is the PD across the entire circuit. Now, how do I approach this? These two resistors, they are in parallel. Then this in series with this single resistor. Now, I'm given the current flowing through this 5 ohm resistor as 2 ampere, but I'm not given the PD across these 10 ohms. Now, the law for parallel arrangement says that when we have two resistors in parallel, the potential difference will be the same, although the currents will be different. Now, I can calculate the PD across this 5 ohms resistor. My R1 is 5 ohms, my R2 is 10 ohms. So if I'm to calculate V1, which is the potential difference across these 5 ohms, I would say V1 equals to IR1, which is 2 times 5. So that means the PD across this 5 ohm resistor is what? 10 volts. Now, knowing fully that the PD will be the same across the parallel arrangements, automatically PD across this 10 ohms is also what? 10 volts. Sorry, PD across this 10 ohms resistor is also 10 volts. So if I equate that now, so I said V1 equals to V2 for parallel arrangement. That means V1 and V2, they are both 10 volts. So for V2 now, that will be I2 times R2. So making I2 solve the formula, I have my I2 to be 1 ampere. That means current of 1 ampere flows through 10 ohm resistor. Now, the current here is 1 ampere. That means the total current that will flow here will be I. Is that okay? So that means the total current now will be I1 plus I2 because the current is branched here, came together here, and flows back into the circuit. So the total current is what? 3 ampere. So it's that 3 ampere current that will flow through this 20 ohms resistor. So to know the PD now, I apply my Ohm's law again. V equals to IR, which is 3 ampere, the total current multiplied by this resistor, which gives me 60 volts. So 60 volts is the current that flows through, is the PD, is the voltage, the PD across this 20 ohms resistor. Now the next question, we have a circuit here, and the question says, what is the effect of closing the key in the circuit shown? Now, when the key is closed, we have something like this. When the key is closed, that means we have 3 resistors. These two are in parallel and in series with this. So when the circuit is closed, when the key is closed, this will be the total resistance, 6 ohms. Because these two are in parallel, which is 8 times 8 over 8 plus 8, plus this two, which is in series. The total resistance will be 6 ohms. Now, to know the current, I apply Ohm's law again, V equals to IR. But I'm looking for the current here. So I make my current solve a formula, which is I equals to V over R. So I equals to V over R, that will be 6 over the 6, which is 1 ampere. So when the key is closed, the current is 1 ampere. Now, when the key is open, what happens? When the key is opened, current does not flow through this resistor again. So that means I have 2 resistors present, which is this 8 ohm and this 2 ohms. Is that okay? So that's what I have here. Total resistance will be 8 plus 2, which is 10 ohms. That is when the key is opened. All right? When the key is opened. So total resistance when the key is open is 10 ohms. So the current will now be 0.6 ampere. That is 6 divided by 10, which is 0.6 ampere. Now you can see the difference. When the key is closed, the current flowing through the circuit is 1 ampere. But when the key is open, the current is 0.6 ampere. So what's the difference? 0.4 ampere. Is that okay? So that means when the key is closed, the current increases by 0.4 ampere. But when the key is opened, the current decreases by what? 0.4 ampere. Now, the last question. We have to calculate the current through the 1 ohm resistor. Now, if you look at the arrangement, there is a junction here, and there is another junction here. So it means these two resistors are in series. These two resistors are also in series, but they're in parallel to each other. The total resistance will now be this 2 plus 2, which is 4. This 2 plus 2, which is 4. So I have 4 in parallel to each other. So that's 4 times 4 over 4 plus 4. Instead of this 1 ohm plus 1, that gives me total resistance of what? 3 amperes. So current through this 1 ohm resistor is the total current through the circuit, because as the current is flowing, it passes through, the current goes this way. You can see this part of the question. So the current enters this 1 ohm first before it's being divided, before it's being branched. So current through this 1 ohm resistor is the same time as the current through the entire circuit. All right, so that's I equals to V over R, because total current gives me 3 ampere. The voltage is 12 volts. So 12 divided by 3. Apply Ohm's law again, V equals to IR. I'm looking for current, so I make I subject of formula, which is V over R. So 12 over 3, which gives me 4 ampere. So the current through this 1 ohm resistor is the same time as the current through the entire circuit, which gives me 4 ampere. Is that okay? I believe you've learned something. Please don't forget to like this channel and subscribe to my channel for more videos. Thank you all. God bless you.